Hi everyone, we're looking at 7.3 using counting methods to find probability. This first question that we're looking at talks about the complement of A, but let me back up. The following table here lists the ages and the number of players per age group that are in a baseball team. So we're going to let A be the set of baseball players who are younger than 10 years old. How many players are in the complement of A? In other words, how many players are 10 years old or older? So if you read it that way, it's going to make a lot more sense. Here's 10 years old. Here's 11 years old. So 7 plus 2, your answer will be 9. So I don't think that one's too hard if you understand what the complement of A is. Let's move on to the next one. Now this problem is going to involve some probability. Well, they all will. But this is going to involve a combination within the probability. Let's take a look. Liam, John, and Charles are going to play video games this afternoon. Together they have 34 video games. If they decide to randomly choose 3 video games, what is the probability that the 3 they will choose consist of each of their favorite video games? Assuming they have different favorites, express your answer as a fraction in lowest terms or decimal rounded to the nearest million. So I went in and I set this up. What we're looking at here is it's a probability, so it's 1 over, because you're picking one option over the possible combinations of 34 video games, choose 3. So if we figure out this combination piece here in the denominator and keep that 1 in the numerator, that'll take care of it. So let's see if we can figure it out. I got my little calculator here. I'm going to do this the quick and easy way. So it's, what did I say? 34 to choose 3. So we're going to go, hold on a sec. Let me expand this window here. I expanded the window. It's 34, choose 3. So remember, I think I talked about this in another video somewhere, how to find your combination. Click this PRB, and then it's option 2 here. And depending on your calculator, it's going to vary how to find that combination thing. If you have trouble finding that on your calculator, just give me a holler and I can give you a hand there. We're choosing 3. So your answer is 5,984 for your denominator. So let's put that in there. Let's see if I can shuffle my windows around here a little bit. 5,984, 5,984. So that's your answer. Your answer is 1 out of 5,984 for this problem with the video game issue. So hopefully that'll help on that problem. All right, I actually had to do a little homework on this one. Let's see if I can do this one. Find the probability of choosing a letter other than the letter S from a bag that contains the 18 letters of the Russian city Kamensk-Shachtinsky. There. I probably butchered the pronunciation, but I think I got it. In any case, that's the city, and I apologize if any of you are Russian or speak Russian, because I know I probably butchered that. Anyway, express your answer as a fraction in lowest terms or a decimal rounded to the nearest million. I chose a fraction. So what is going on here? Well, first of all, there are 3 S's in Kamensk-Shachtinsky. So, and there are 18 total. They tell us that. So 3/18 of your letters are the letter S. Subtract that from 1, which is a whole. So 18 out of 18 minus 3/18 is 15/18. Or reducing that to 5/6. I want to check something. Let's see if it'll let me do 15/18 and do this without my face-to-face students say that you don't have to reduce. Yeah, that's what I thought. That was for a different section, so I think they want the 5/6. So make sure to reduce it. Let's see if we're right. There you go. So make sure to reduce when you get your fraction answer on this one, all right? Of course, if you do this as a decimal and just take your 15/8 and divide it by, 15 divided by 18, it'll get a decimal answer and just round accordingly. But if you're not very good at rounding, the fraction is probably your best way to go on that. All right, this one I think is going to be the hardest one in this section, so let's make sure we understand what's happening here. A committee of 3 is being formed randomly from the employees at a school. There are 5 administrators, 34 teachers, and 4 staff. So from these people, we're going to form a committee of 3. What's the probability that all 3 members are going to be administrators? and then express your answer as a fraction or a decimal. I'm going to go with a fraction because I usually do. So how do we set this up? I went ahead and I created this little help sheet, if you will. Order doesn't matter here. You could pick your first person on your committee, and it could be from any of these. It's not like the first one has to be an administrator, the second one has to be a teacher or something like that. No, order doesn't matter at all. So that means we can use combinations. And our combination, we have to do two of them. First, we have to find our options if we're just going to pick from your list of administrators, right? We're going to look at, because they're saying, what's the probability that all three are administrators? So you got to look at all the options where you are picking strictly from administrators, and you got to divide that by the total options that are there. Now, if it had asked, what's the probability that all three were teachers, then you would have picked all your teacher options divided by your total options. But since they're asking for administrators, here's what we're looking at. We're looking at there are 5 administrators total. So what's the probability that, or what's the combinations that we'll get if all three of them are administrators? So 5, choose 3. Divide that by your total options of 43, right? That's all your people, all your administrators, your teachers, your staff, all added together to get 43. You choose 3 of them. Okay, so we'll figure that out. I'm going to use my little handy dandy calculator here. 5, choose 3 over 34, choose 3, right? 43, choose 3. So I'm going to use parentheses here. Let's go parentheses 5, and we're going to choose 3. And we'll close that off. I'm going to see if this works. I'm not sure if it will. I think I tried this once before and it didn't work, but we'll see. Divided by, and it's 43, choose 3. 43. Nuts. That's not what I wanted to hit. 43. This button. Choose 3. Close parentheses. And okay, I guess I got a decimal answer, which is fine. I guess we can answer this as a decimal. I'm going to put this off to the side so you won't be able to see this, but I will. Maybe. Nuts, hang on. Alright, so I went ahead and I shuffled things around here so that I can see what I need to see. So 0 point, let's see, we got the tenths, hundredths, thousandths, 10,000ths, 100,000ths, and we're nearest millions, so here's your millionths place. We'll round to that place because the next number is a 3. If that was a 5 or bigger, then I would have made the 0 or 1. I think that's my answer. Let's see if we're right. Hey, what do you know? We got it. All right, this one, it is presentation day in a class. Your instructors draw names from a hat to determine the order of presentations. There's 19 students in the class. What's the probability that the first 3 will be by Mila, Todd, and Kelly in that order? Oh, this is a permutation. Give me just a sec. Let's set this up. Actually, I'm living on the edge. Let's see if we can get this right off from the start. Well, it's a probability, so I know it's going to be 1 divided by, and like I said, it's a permutation, and it's 19, choose 3. So I'm going to go 19 and go to my probability thing here, and it is a permutation, so that's the one I want right there is option 1. It's a permutation because order matters. Order matters because the first one's by Mila, and then Todd, and then Kelly. I mean, they're specific about how they want this to be. That's how I'm seeing this. We'll see if I'm right. We're choosing 3. Hit enter. And we went to the nearest millionth, so I'll enter in my answer. 0 points. Let's see. We got the tenths, hundredths, thousandths, 10,000ths, hundredths. Millionths is next, but I need to write a 2 because that 9's rounding this guy up to a 2. Let's see if we're right. Oh, we're killing it, guys. All right, this one could be a little tricky, too. So let's see if I could shed some light on this. Julia sets up a passcode on her tablet, which allows only 6-digit codes. She has heard that it's more secure if a digit is repeated on the passcode. A spy sneaks a look at Julia's tablet and sees her fingerprints on the screen over 5 numbers. What is the probability that the spy is able to unlock the tablet on the first try? And then, of course, the usual how to write your answer. Now, there's two things going on here. The first thing we've got to look on is the digit that gets used twice. And the second thing we have to look on is the order of numbers in the passcode, which is going to be reminiscent of that one problem where we found the possibilities with the whole date of birth thing, which you probably don't remember. That's okay. So what we'll do here is we'll first look at the digit that gets used twice. Now, 5 of those digits, 5 numbers get used twice, so it means we got 5 numbers here. One of them gets used twice, so 5 choose 1. We'll get 5 out of that. All right, so that's established. Next up, we're going to look at the order of your numbers in the passcode. So that's what I was trying to say. It's like that Disney, or not Disney. I mean, there is a problem to deal with Walt Disney, but you probably haven't seen it. But the one about you look at your date of birth and the probability of finding it, etc., etc. Anyway, if you don't remember it, no big deal. We're looking at 6-digit codes, so we'll put 6 factorial in the numerator. And then in the denominator, we're going to have 6 options, a 2 factorial about the repeated number that gets used, and then the other 4 numbers that'll add, all these numbers downstairs should add up to 6, right? But they're all factorials. So really, you're just looking at 6 factorial divided by 2 factorial. Long story short is you've got 360. Now you have to look at the overall probability, and to get that, you're just going to have 1 over 5 times 360, which is 1 over 800. Or excuse me, 1 over 1800. That right there is your answer, folks. Number 7 here. Let event E be the sum of a pair of dice that's greater than 7. We're going to look at the events that the complement of that. So, if you think of it this way, the smallest you're going to have when you roll dice is snake eyes. 1 plus 1 is 2. The largest you're going to get is 6 plus 6 is 12. So we're going to look at everything in between and pick the complement of greater than 7, which means we're going to pick everything less than or equal to 7, okay? So let's see if I can figure that out. Everything less than or equal to 7. So we've got 2, 3, 4, 5, 6, 7. And I don't think they want brackets or anything. Let's check and see. Yeah, that's what they wanted. All right, this one I don't think is going to give you too much trouble if you know what you're looking for. A local pizza parlor has a following list of toppings available for selection. Parlor is running a special to encourage patrons to try out new combinations of toppings. They list all possible 3 topping pizzas. That's 3 distinct toppings, so it's going to be a combination, on individual cards, and give away free pizza every hour to a lucky winner. Find the probability that the first winner randomly selected draws a card for a pizza topped with black olives, spinach, and spicy Italian sausage. So again, we got 3 there. Express your answer as a fraction in lowest terms or as a decimal, etc., etc. Now, let's take a look at our options we've got. Let's count them as we go. Green peppers, that's 1. Onions, that's 2. Kalamata olives, that's 3. Sausage, that's 4. Mushrooms, 5. Black olives, 6. Pepperoni, 7. Spicy Italian sausage, 8. Roma tomatoes, 9. Green olives, 10. Ham, 11. Grilled chicken, 12. Jalapeno peppers, 13. Banana peppers, 14. Beef, 15. Chicken fingers, 16. Red spinach, 17. Spinach, 18. Bacon, 19. Anchovies, 20. Artichoke hearts, who would do this? Let's count, 21. Sun-dried tomatoes, 22. Canadian bacon, 23. And extra cheese, 24. 24 options. We're going to choose 3. Here's your setup. It's 1 over 24, choose 3. And once you figure that out, I'm going to let you guys do that. You should get your answer. All right, this problem is very similar. This is number 9 that I've been given. It's very similar to a previous one I did in this very video, so I'm going to skip that and go to the next one. The last problem I was given is just like the couple problems that I just got done doing, so I'm going to leave that for you as well. All right, this is kind of a crazy section. Hope you guys are okay with what happened here. If you have questions, definitely get a hold of me.